the webinar is about 45 minutes to an hour, and then after webinar I'm open to question and answer session. And then what I'll do is I'll try to connect the few dots in engineering area from design to engineering, and then I move to CAE, and then finally I narrow down to MSc Nastran. After a brief introduction of MSc Nastran, we go through a simple case study demonstrating the capability of MSc Nastran and the Patran combined, and then finally I'll conclude my webinar with the opportunities available in MSc Nastran and what are the prerequisites for this to entry into this career. So I hope everybody is clear about the agenda. So let me start here, right? And before starting into exact session, so let us revise a few terms that forms the precursors to our subject of interest. So whenever we come across any product or anything, right, we come across the term called design. So now if you look at the term, right, so what exactly mean by design? Now when you look at the design, the simple definition I can put is the design is a plan, okay, and implementation of which results into a product, a service, or a result. Okay, so for this webinar we'll restrict our design only for a product, wherein it means a physical product wherein it occupies some space, and then it has got we can feel and touch and feel the product. So we'll restrict ourselves to a physical product. Now we come across another term called engineering. So what is engineering? So engineering is nothing but it's a way to manifest a design, and then engineering is the understanding of our natural world in a scientific manner, and then apply this rationality to invent and design and build the things and to solve the problems to achieve practical goals. So please remember here, engineering is all about solving the problems and achieve practical goals. So let's look into design process or a design framework in a more broader manner. So when we come across any design, right, design process as a process is guided by a particular design framework, wherein in design framework we have got a design philosophy and combined with other two auxiliary parameters or auxiliary terminologies. So what is this design philosophy when we talk about a product design? So the design philosophy, right, it is a combination of three factors or three terms. One, we call it as a fit, form, and function. So whenever we have whenever we want to design a product, the product has to comply the design philosophy comprising of these three terminologies. So what do you mean by fit? Fit is nothing but the product has to occupy its spatial distribution. Okay, and then what do you mean by form? Form is nothing but whenever we design a product, the material, the manufacturing process, and the assembly process has to be feasible. So we cannot create something out of blue which is unfeasible. It has to be feasible. And then most important is function. So what is meant by function? The product or the component whatever we are designing has to perform its intended function. So then only we call it as a product, and we can make use of this product. So all these parameters, all these fit, form, function has to be complied when we design a product. Now apart from that, when we talk about the design of any physical product, we have got auxiliary parameters or auxiliary terminologies that we come across. So one is called a load path. So what is meant by load path? Right, whenever any physical product is designed, it is either it can be a source of energy, or it can be a source of force, or it can be a transmitter of force, or it can be absorber of a force. So in either way, it has to, the load the component. Okay, so to design a product in a better way, or the understanding of the load, how the particular component reacts, or how particular for a particular load, that is very essential for a designer. So for this we need to have a clear understanding of the load path. Next term comes the failure mode. So you might be wondering why we are talking about, when we are designing a better product or a durable product, but why we are talking about this failure mode. See, whenever we design a product, we are not building the design, or we are not building the product for an eternity. every product has its own lifetime. Okay, so within that time frame the product has to operate and fulfill its intended function. Now when the time frame is completed, or when the time frame for a particular product is over, it has to fail in a graceful manner, or from a designer's perspective or an engineer perspective, it has to fail in an intended manner. When it fails, without warning or in an unexpected manner, then obviously there will be a loss of life or loss of property. So the simple example I can give you is, maybe you might have a lot of time, you can see, you read about in the newspaper that so and so building collapsed and so many people died and all, right? But why this happens? Because first thing is failure, we don't know the failure. Okay, and I mean, failure is, it is always an unexpected event where we can't predict the behavior of the structure. But at the same time, if you compare this phenomena with the demolition of an old building by municipal authorities or town planning authorities, wherein the structure is demolished using a process called a controlled detonation, wherein you see, I mean, a lot of videos are available in YouTube, wherein the structure collapses in an inward manner, so that even flying of debris and all have a least impact on the adjacent structure, right? So adjacent structure, so, and obviously there will be no loss of life as long as we are controlled and all the particular precautions are taken care of. So this is why we define, whenever we design the structure, it has to fail in a proper manner. Now if the structure can fail in a multiple manners, then we need to define what is the critical way that it can fail, and then we need to make sure that the structure fail in that manner only. So this is how we design the structure, and this is what we call as a design framework for a structural design. Now when we do all this process, when we mix all these ingredients, ultimately what we get is an efficient design or efficient product. So how it is efficient? It is efficient in terms of cost. Okay, the cost is all the process or a design process or a manufacturing process is done within the allocated budget. And then the quality means the product is doing its intended function, and then it has got it, all the design parameters are met, all the customer expectations are met, etc. And then third is schedule. So the so the product is coming into the market within the well defined or within well planned time frame. So this is what we got as a product. Okay, so now when we say, right, now let's look into a little bit more into stages of the design. You might be studied already in your machine design subject or elements of design subject, right, various stages. So let's I'll not going in through detail, but let's touch upon these. So first is always recognition of the need. I mean, these are the general steps. Maybe there are maybe addition or maybe a reduction of few steps here and there, but it's a general process wherein we recognize the need, and then what we do is we convert all these qualitative parameters into a quantitative parameters by defining the problem, which are like more in terms of for a designer to work on. And then we do the analysis, and then a synthesis, and then a prototype building, and then testing of the prototype, and then ultimately product goes to a market. But what happens, right, nowadays, this was the once a traditional design cycle, but with an advent of computers, what happened, we are more relying into computer into every aspects of our life, and then wherein this product design is of no exception. So now we are engineering task, we are talking about computer aided engineering. So where this relevance of the computer aided engineering comes into this product development process. So roughly it covers the following phases: the analysis, synthesis, and the prototype building phase, wherein our dependency on a typical prototype building and then testing the prototype to assess the performance of our design or a product has become less and less with an advent of computer aided engineering. So what do you mean by computer aided engineering? Now when we talk about computer aided engineering, right, it's a set of digital techniques acting to support design that allows simulate the behavior of the component structures and complex systems in their respective operating conditions in a virtual environment. So please note the keywords. One is the behavior of the structure, and then operating conditions in virtual environment. and it also aids or helps in the improvement of a design, and then by solving engineering problems. So you might be wondering now at this stage, we have a real structure or a physical structure in reality. Let's take aircraft or a car or any structure, and then how come we are able to solve these or simulate this structural behavior into a virtual world? So what is the basis of this? So there is a simple, I mean, maybe you might be expecting finite element or equations and all those stuff. That may be a very advanced stage, but to give you a brief one line answer, why we are able to simulate all these virtual, all these real phenomena or realistic phenomena into a virtual world is because the physical behavior of the structure always obeys laws of mathematics. So because of we are combining laws of physical behavior and laws of mathematics, that is why we are able to simulate everything with related to structural behavior in a virtual world. So I'll just give you a simple example. Okay, so when you're studying your strength of material, right, the classic thing or the first thing what you study is you study the problem of a rod which is subjected to an axial tensile load. Okay, now think of the same problem again. So when the rod is subjected to a tensile load, okay, so the what is the physical phenomena it experiences? The physical phenomena what we see is the extension of the rod. Of course, there is also a reduction in cross section, that is also matter, but right now just consider the extension of the rod. So when the rod extends, right, what it goes? It goes undergoes a deformation. So how do you define the deformation? Right, one is a simple mathematical simple mathematical formula saying that one is a final extension, one is the initial extension or initial position, and then final position. The final position minus initial position is your deformation. But in a more generalistic way or in a more realistic way, how you can define this linear extension? By defining, equating to the equation of a line. So how do you what is the equation of a line? Please remember your graph theory, y equal to mx plus c. So with this we can simulate, or we can I mean, this can be extended to various types of deformations for a structure. That is what this engineering is, or C process is. So this is how we are able to define the structural behavior. I mean, this extension of a rod is a very small example. So this is what we have. This is what the basis of a CAE software development, wherein we are able to express the physical behavior in terms of laws of mathematics. And then typically, right, when we have a CAE, when we look into CAE software as a whole, okay, basically it can be categorized into three different categories. One is the process simulation, wherein these kind of softwares are more employed in petrochemical industries or a chemical industries of sort, wherein more temperature, fluid, pressure is involved. So the typical example of these softwares are one is Simulate or Arena or a Factory CAD. And then second category of software is called a design validation software, wherein we try to assess the behavior of the structure, or we try to assess the performance of a structure against predefined design conditions. So the typical example is a Nastran or ANSYS or a Fluent or LS Dyna. All are typical design validation software. And the third category of software is called optimization software. So the optimization software is a slightly different, even though design, there is not much difference between design validation and optimization, but there is a thin line exists between these two categories of software, wherein we try to optimize the product to meet the specific design requirements. So typical optimization softwares are OptiStrat or a Genesis, and maybe you can say OptiShape module of MSc Nastran, etc. Okay, so now if you want to have a more clarity on what is the difference between design validation and optimization, I would love to take it up in question and answer session. So now, what are the typical advantages of CAE? Okay, so one now we already seen, right, the CAE encompasses the approximately three stages of product development cycle, wherein it makes us less dependent on a physical prototype for the assessing the performance of structure. So thereby what will happen is the product development time is shortened. Okay, and then this shorten of product development makes us makes in results in a less reduction in cost, and then by it increases the design efficiency. So how does it increases design efficiency? So this implementation of CAE software, answers, it enables us to try the classic scenario called what if scenario. So for a particular, as a designer, you can think of the multiple ways. What if I use instead of steel, if I use aluminum, or what if I use, instead of a square cross section, if I use a rectangular cross section or an I section, or what if I use, instead of welding joining process, if I use nut and bolts or a rivets. Like this, multiple scenarios, be it in terms of a material, or maybe in terms of configuration, or in terms of a geometry, all can be tried out either individually or in a simultaneous way with a various types of permutations and combination, and all these can be tried out in a very cost effective manner before the prototype is being built. So thereby, right, with all these, it obviously results in reduction in cost for a particular product development cycle. And then apart from that, there are another added advantage of CA is, one is the flow of information is seamless, wherein everybody talks about the same language, right from a design team to a marketing team, everybody talks in the same language, which is understandable by everybody, and then obviously it will result in a quality improvement. So now, when we briefly looked upon the CA softwares and then types of CA softwares, now one prominent name stands in this among the CA software is is called MSc Nastran. So just give you a brief history of Nastran. The Nastran is an acronym which stands for NASA Structural Analysis Program. So earlier in 1960s, it is developed by NASA, US's Space Administration establishment, to cater the aerospace community. So initially it developed, and then it was a proprietary program of NASA. And then over the time, what happened, as the program becomes more and more mature to simulate wide variety of problems, the NASA found it economically unviable to maintain and enhance the software. So it gave this software on a franchisee basis to private players, wherein many private players took the source code of this Nastran and then try to enhance the capabilities on their own. So what happened then, when they tried to develop, there were like so many versions of Nastrans were available over a period of time, and then maybe because of the normal industrial process like merger, acquisition and all, now very few versions of Nastran are left out in the market. So one such leading brand is MSc Nastran, developed by MSc Software Corporation. Then we have got another 2-3 brands of softwares. One is called NX Nastran, which is owned by Siemens, and then one is AA Nastran, which is owned by Autodesk Inc. Okay, so the speciality of this software is it is entirely written in Fortran language. So you might be aware that Fortran, I'm not sure whether the is aware of the Fortran language. When I was studying in my engineering, Fortran language is one of the choicest language for engineers, wherein it used for a scientific application in a wide, it was being used widely. So the Fortran stands for formula translation, and even though the usage has become almost the Fortran language has almost become extinct now, but still the Nastran is whatever the newer capabilities for Nastran is being done, it is done in Fortran only till now because of their operational difficulty. So now, as far as the usage of Nastran goes, MSc Nastran goes, wide variety of industries, or in wide variety of product domains, it is being used as a product development software. So right from defense to automotive to aerospace to medical devices to surgical implants to even the companies which are involved in designing of kids diapers, everywhere this Nastran goes all along. So one more thing I would like to point out here, that whenever I say Nastran you can imagine it's just a vehicle, okay, to carry out the analysis program. So the Nastran always comes along with a software or along with a package called Patran. So the Patran is an external interface to Nastran. So Nastran and Patran goes hand by hand. So whenever I say Nastran, please note that I'm talking about Patran as well. Patran is always an implicit presence in this terminology.